Hello, today we're going to take a look at reciprocal trig ratios. So what do we mean by that? Well, reciprocal, remember when we're talking about reciprocal of a fraction, we're talking about flipping that fraction. And that's basically what we're going to do here with sine, cosine, and tangent. So what I've got written out are those ratios that we learned before. Opposite over hypotenuse is sine, adjacent over hypotenuse is cosine, and opposite over adjacent is tangent. But we can also have reciprocal ratios. That's when we flip these fractions. And we flip them, we get these right here. This is abbreviation for cosecant. So if you were to spell it out, it would look like this right here. This is secant. And then this is cotangent. And so when we flip this one, I get hypotenuse over opposite. Flipping this one, I get hypotenuse over adjacent. Flipping this one, I get adjacent over opposite. And that's pretty much all there is to it. But I want you to remember something here. A lot of students get confused when they think of the reciprocal of sine. They think the wrong thing, secant there, because they see S and C, and that messes up students, especially because this one says cosine and this one says cosecant. So what I want you to do to remember that is to remember the fact that S pairs with C, okay? So S pairs with C, S here pairs with this C. So keep that in mind so we don't get these confused. The reciprocal of sine is cosecant, the reciprocal of cosine is secant, and then tangent's pretty obvious because the reciprocal of tangent is cotangent. All right, so if I'm looking at something like this, I give you the sine of theta equals 3 over 4. That means the opposite side is 3 and the hypotenuse is 4. Well, the cosecant of that is just going to be the reciprocal, which is 4/3. Sometimes I don't give you something as straightforward as that. I might say the tangent of theta is the square root of 2 over 3. And so what is the secant? Now notice I didn't ask for the cotangent, I asked for the secant. So we need to figure out one other side of the triangle because tangent is opposite over adjacent and then secant is hypotenuse over adjacent. We don't know the hypotenuse yet. So go ahead and sketch out a triangle, mark a theta there. Remember theta is one of the acute angles in a right triangle. And then we're going to mark out these sides. The opposite side is the square root of 2, the adjacent side is 3. And let's use our friend Pythagoras to figure out the hypotenuse. So I'm going to say 3 squared plus the square root of 2 quantity squared equals the hypotenuse squared. This gives me 9 plus 4 equals the hypotenuse squared, or 13 equals h squared. Square root both sides, and you get the hypotenuse equals square root of 13. And so now I can say square root of 13 over the adjacent side, 3 is my secant. All right. Some people like to still figure out cosine and then flip it. You can do that as well. But if you've got this written out, you can kind of just look up here at your guide and figure it out that way. All right. Let's look at some other, well, let's actually just kind of formulate these all out like this. Just to kind of mark down some identities that we haven't really, we might have talked about some, but we haven't clarified or organized or written them out yet. One thing I want to show you here is that the sine is also equal, we know it equals opposite over hypotenuse, but we could also say it equals 1 over cosecant of theta. And so we might be like, well, how does that come about? Let me show you. It all goes back to just doing regular old fractions. If I were to say 1 over cosecant, think about what that means. That means we're going to take 1 and divide it by, well, cosecant is equal to hypotenuse over opposite. And so if I treat this as a fraction, put 1 over 1, I've got 1 divided by cosecant here. Cosecant is hypotenuse over opposite. Well, that's when I'm going to say, okay, keep the first fraction the same, switch to multiplication, and flip this thing. And so I got keep it, switch it, flip it, and when I multiply out, I get opposite over hypotenuse, which is still the sine of theta. So this is 1 over cosecant theta. I made it 1 over hypotenuse over opposite. And working out the math, just like when you divide a fraction by a fraction, I still get sine theta. And you can do that with all of them, where you say this is 1 over cosecant, cosine is 1 over secant. For the same justification, tangent is 1 over cotangent. And likewise over here we can say cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. Now you might be wondering, why are we doing all this? This comes in pretty handy when we start talking about proving trig identities. So we will see this later on, and you will have to be able to pull these out and use them to solve problems. So hopefully not too complicated just yet. It's just getting used to seeing them in different forms. But speaking of other forms, let's look at the bottom down here with the quotient identities. Now, we know a couple things about tangent. I know tangent equals opposite over adjacent, and I just said right here that tangent equals 1 over cotangent. But we also talked about on the unit circle that tangent equals the sine divided by the cosine. Remember, we talked about it saying it was the slope of that line on the unit circle, which was our rise over our run. And so we can also write out tangent like this. So tangent is opposite over adjacent, sine over cosine, 1 over cotangent. Sometimes we will use, well, we'll come to a situation we have to decide which one of those to use. And so being familiar with all three will help us solve problems later. But we did say that if we flip the tangent, opposite over adjacent currently, but if we make it adjacent over opposite, we get cotangent. So because of this identity, we flip that fraction, we can say cotangent also equals cosine of theta over the sine of theta. So the reciprocal of our tangent function is cotangent. So that's another way we can write cotangent. It's 1 over tangent, it's adjacent over opposite, and it's cosine over sine. So these identities will be helpful, and we're going to learn more identities as we go through the trig unit. Let's take a look at a few example problems using reciprocal ratios now. Our first is this one right here. Evaluate for all 6 trig functions. So we have pi over 6. Now, pi over 6, remember on the unit circle, looks something, well, it's this triangle right here. If you haven't watched my video on unit circle, go back and watch that because I take you through using triangles to show the different angles on a unit circle and the different trig values. And so here's one of the triangles from that video where we said if this angle right here is pi over 6, then the cosine is going to be square root of 3 over 2, and then the sine is going to be 1/2, and then we're going to talk about our slope there to get tangent. So once again, the sine is our y value here, or 1 over 2. Our cosine is going to be square root of 3 over 2. Our tangent, we could do a couple things. If you don't remember the tangent, you can say it's 1/2 divided by square root of 3 over 2 and work out that fraction. I like to think of it as the slope of this line right here. It's our rise of 1/2, our run of square root of 3 over 2. That is our opposite over our adjacent, the slope of that line there. And when we talked about the unit circle and slopes on the unit circle, we said we had a few options. We had 0, we had undefined, square root of 3 over 3, we had 1, and the square root of 3 here. And these could be plus or minus on each one of these. And this one is the more shallow. The other one, the square root of 3, looks like this. That's the steeper slope. And then a slope of 1 looked like this right here. That's our 45, 45, 90. So we have the slopes were square root of 3 over 3, 1, and square root of 3. This one is square root of 3 over 3. So that's going to be our slope here. And now simply to find the reciprocal ratios, I'm going to flip all these fractions and I'm going to rationalize when possible. So flipping this, I get 2 over 1, which equals 2. Flipping this one, I'm going to get 2 over the square root of 3. We do need to rationalize that, so I'm going to multiply by root 3 over root 3. That's the same thing as 1, but what it does is in the bottom it gives me just 3, and I get 2 square roots of 3 right there for my answer. And then pi over 6, I'm going to flip this. I get 3 over root 3. Once again, we're going to rationalize by multiplying by root 3 over root 3. And this gives me 3 square roots of 3 divided by 3 here. Notice the square roots of 3's cancel, and I get just square root of 3 right here. All right, so that's one of them right there. That's evaluating for all 6 trig functions when theta equals pi over 6. Let's look at another. On this one, it's going to be 5 pi over 4. So when I do, excuse me, when I do 5 pi over 4, I like to think about it on the unit circle and say, where is 5 pi over 4 at? Well, I know that pi over 4 is like my 45-degree marks if you're thinking about it in degrees. So it's 1 pi, 2 pi, 3 pi, 4 pi over 4. Right here is 5 pi over 4, and it's the 45-degree angles. So I am looking at one of these blue triangles like this right here. So I'm going to go to the left, a negative square root of 2 over 2 to the left, and then I'm going to go down negative square root of 2 over 2. So that is both my sine and my cosine. It's going to be negative root 2 over 2 and negative root 2 over 2 there. Notice the slope of this line is my rise over my run, which is going to be just 1. And so when I flip that fraction, it's going to be 1 right there as well. Flipping this fraction, I get 2 over square root of 2, and this is negative. And so I want to rationalize that denominator, so I'm going to multiply it by root 2 over root 2. And this is going to give me 2 in the bottom and negative 2 times root 2 right there, but the 2's are going to cancel. I'm left with negative root 2 here. This is going to be the same thing because it's the same fraction being flipped, negative root 2 there. All right, let's move on to the next one. We only have a couple more here to go. Excuse me, my throat needs to be cleared today. So we've got theta equals 0 here. Remember that on the unit circle, it's going to be right there at the beginning where that initial side is. So there's my circle, here's my initial side, there's theta at 0. And remember my xy coordinate there is going to be 1, 0. So the sine value, remember, is your y value, and the cosine is your x value. It goes in alphabetical order. So cosine is 1, the sine is 0, and the tangent here is the slope of that line, which is 0 there. Now, you can make these fractions if you want, so we can put them in over here a little bit easier. We can flip them easier. And flipping this, I get 1 for my secant. But flipping this, I'm going to get 1 divided by 0, which is undefined. Flipping this one, I get 1 divided by 0, which is undefined. And so be careful with those. Sometimes when you flip them, you do end up dividing by 0, and you want to make sure that you write that down as undefined as it should be. All right, let's look at this one right here. This time we're going to evaluate it for pi. So here's my unit circle. And remember, pi is going all the way around this way. Right here is where pi is. And what are the ordered pairs there? Well, we've got at negative 1, 0. So remember, again, alphabetical order, cosine and then sine. My cosine is negative 1, but my sine is 0. The tangent here is still 0 because the slope of that line is 0. When I flip this, I'm going to get undefined. When I flip this, I'm going to get undefined again. And when I flip this, I'm going to get negative 1. Almost like the last one because the sine and the tangent were the same there, but the cosine changed, so we see a change there at negative 1. Real quickly, because I don't have it in an upcoming example, so I'm going to go ahead and talk about it here. If we were to look at, say, pi over 2, the tangent of pi over 2 equals undefined because the slope right there at pi over 2, the slope of a vertical line, is undefined. But the cotangent, this is the same thing as saying 1 over 0. If I flip that, the cotangent of pi over 2 is going to give me 0. Because you flip this fraction, you get 0 over 1, which is defined, and you can say it's 0 there. So keep that in mind. I didn't plan out an example like that, so I just thought about it. When we flip undefined, if you will, we're going to get 0. All right, let's look at one more. This one's going to be a negative angle. And so what about when theta equals negative pi over 3? So let's take a look at that on the unit circle. Negative pi over 3 is going to be going this way. So it's going to be right down here like this. Now remember that pi over 3 comes from this triangle right here, our 30, 60, 90 triangle. And it is not this angle, that's our pi over 6. It's this one, our pi over 3. So it's a triangle that looks like, look at that, I drew it perfectly there. That's how long I've been doing this stuff. This right here is pi over 3. And so that's what our triangle looks like. It's oriented just like that, where the x value is positive 1/2, and the y value is negative root 3 over 2. And so remember, we've got cosine and then sine. Those are our values there. So the cosine value is 1/2, and the sine value is negative root 3 over 2. let's go ahead and flip these just to get them out of the way. We've got 2 over root 3 and it's negative, and then we've got just 2 right there. Let's rationalize that denominator. So I'm going to multiply by root 3 over root 3, and I get negative 2 times the square root of 3, negative 2 times the square root of 3 over 3. That's my value there for cosecant. For secant, I get 2. Now let's talk about tangent. If I go back at looking at this right here, this is the steeper slope. The other option would look like this on this triangle. And then don't forget we also have the 45, 45, 90 looking like this. So as I look at these slopes, this slope is 1, talking about the slope of the hypotenuse on the unit circle. And then the other two options are root 3 and root 3 over 3. This is a shallower slope because it's a smaller number. So it must be this one right here. By the way, it's not just 1, it's negative 1 because it's going downhill. So this is the shallower number. It's going to be negative root 3 over 3. This one's a steeper number. It's going to be going downhill faster, or negative root 3. And this is what my tangent is. Negative root 3. Once again, you could always do sine divided by cosine here. If you wanted to, you could say sine divided by cosine gives me tangent. But if you know those three numbers and understand the steeper slopes are larger numbers, it will make you know the tangent of these common angles a lot faster. Now, that means the cotangent must be the reciprocal. So if I take negative root 3 over 3, put it over 1, and flip it, I get this right here. Then rationalize that denominator by multiplying by root 3 over 3, and I get root 3 over 3 negative. All right, so multiply by root 3 over root 3, you get this right here, which notice was my other option for tangent. We're going to see that these reciprocals on the common angles in the unit circles are going to be one or the other, either root 3 or root 3 over 3 when you're dealing with one of them. The other one is going to be present when you're talking about the reciprocals. And that is our 6 there for negative pi over 3. Okay? I plan on making a video with a lot more examples like these that we can go through together, but I wanted to give you an idea of what reciprocal ratios are when we're talking about trig functions and how do we apply them. We will see them a lot more when we get into proving trigonomic identities. Okay? So let me know if you have any questions. I hope you're having a great day. Thank you for watching.